Hey guys, can you hear me?
Yes, I can.
Can you see me?
Yep.
Okay. And how about my desktop? It's coming up. There it goes.
Yeah, looks good.
Okay. So do you have an update on the LTP thing, Kenny?
Yes, I do. I have I have vouchers for 2 out of the 3, and the third one it had to go through another special approval, but that is done. I'm just waiting for them to give me the voucher for it.
Okay.
So we're like 90% of the way now.
Okay. you can just to make our folks happy about it, just email out whatever you have
Okay.
so that they will know that it's coming because they have no idea.
Okay.
So just keep them happy. Okay, so let's who's here. We have Jessica. Hi, Jessica. How are you doing? Jessica is muted. She doesn't want to talk to us.
Yes, I'm here. I have to just get ready. It's Friday afternoon.
I know. That is the problem with Friday afternoon. It's it is time for you to start relaxing, but then we have this class, and then you have to attend it, and that's the problem. So we will, as I said, we'll make it interesting. So I will do slightly more complex exercises today on the context of using virtual private cloud. We'll understand the ability of creating high availability scenarios. I'll be recording. Let's check. Can you check, please, for me? Are we recording this thing? I will also check.
Yes.
Please check.
Yes, yeah, it's red blinking.
Okay, it's recording. That's okay. Good. Nice. So what I was talking about is let me pull up this whiteboard which I write on, and what I want to do is see if I can use a new whiteboard today. I mean, this is mostly silly, but I'm going to try. I'm going to give it a try because what has happened is our company Microsoft, they have this product called Teams, and this is basically originally it was Office Communicator, then it became Link, then it became Skype for Business, and these days it is now becoming Link. This Teams product. And so what we have is now access to Teams. And doesn't mean that we have to use it, but apparently I wanted to use because somebody wants me to try it out. So I just give it a shot. What I have done is I invited you as guests in this team. This is a new team I created, 2018 Spring Cloud Bootcamp. And all of you have invitations. Did you receive any?
I got it.
I got it as well.
So what this does is, what basically it does is it gives you and I access to a notebook. And that is basically OneNote that you probably already use. So I can open this in OneNote and then just write in OneNote. When I do that, all my handwriting that I have here, which is currently in this notebook, I can make it available to you by just using this pen and this blue colored ink and just write on it like that. So I can very easily give you my handwritten notes simply by creating a new page and saying, I'm going to talk about virtual private clouds today. And then I use this notebook to describe the idea. And while doing that, this notebook automatically reaches you. Or rather, I should say, you should have permission to access this notebook already. You should be able to access this notebook by going to the Microsoft Teams invitation that you have, which will bring you straight to this location where I have written down this notebook, where apparently the notebook itself pops up inside Teams. And that is nice, but I want to use it inside OneNote. So I go back there, and it's easier to consume and draw and even erase. And so that's the thing that I like about OneNote, is that it's a little bit different. Although I'm still getting used to this writing using OneNote. It is still not my in my habit yet, but you should have access to it. You should check it. I'm going to give this a try and see how it works out. And what this basically gives you is the ability to access this set of OneNote notes that I will use to write. I will use to fill up whatever I have here, and whatever I draw. Sometimes I keep drawing like that, and this will become available to you. I don't know if that is useful to you at all or not, but that's what I have. So I'm going to give this a shot. Otherwise, we have the other way also, the Notability way, which I never gave you a copy of all this, but it becomes a PDF file. I'm not sure, but if you're interested in accessing this ugly handwritten notes, but if you want it, I can give it to you. And another way is this OneNote notebook, which is also going to be available to you through this invitation that I have invited you, all of you, into the team. They call it teams, and you are guests in the team. And that's one thing that I wanted to talk about. So you should have access to it by default. By the way, you don't have to go get access right away. It also gives you a bunch of features, like we can also like chat like we do in Slack. We can also do a bunch of variety of features. I'm not sure if you're interested or not, but if you're interested, we'll use it. A couple of other things I want to talk about is that, as a part of you attending the Cloud Genius Bootcamp, all of you get access to what I call Office 365 services as a part of your school account. This is the Cloud Genius School. Cloud Genius, by the way, is a school. It is different from Bellevue College. So you are entitled to receive a Cloud Genius email address, pretty much like this. Whatever you like at whatever you like here at Cloud Genius is the email address I can provide you. That will become your school account. It gives you access to all of Office 365 services. It gives you access to all of Google G Suite services also. So we have both. And by the way, this is not limited to the duration of the bootcamp. The bootcamp will finish whenever it does, like May 25. But this access will keep on continuing because it doesn't expire. These are educational benefits that the school has. And as a result, I receive Office 365 subscription and Google G Suite subscription for free from these companies, Microsoft and Google. They give it to us for free because we are an educational institution. So what I do is I give you free access. I'm not sure if you're interested or not, but some of you may be, and so if that's the case, you need to tell me that you are, and I will create an account like this for you. There are a bunch of other people that have taken the program, and many of them are interested. So you may also be able to get a school account like this, and you can use it. It gives you access to these services and also these services from Google G Suite and Office 365. But let's cut straight to the chase. What's the real benefit? Not much, honestly, not much. You already have access to Office through Boeing Company or other places. You might get access to G Suite if you want. It's not that expensive. So there's not much benefit as such. But there is one thing that I want to give you careful attention to, and that thing is kind of sort of interesting. And I'll tell you what it is. So go to this location called drive.google.com. It's a part of the Google Drive services. If you here look at my settings in my Google Drive, you will see that I'm using how much? 1.2 terabytes of storage in the Google Drive. I mean, this is the consumed storage, by the way. Let's see how much actual storage I have access to. So I'm going to view details and find out that I have access to, and not just me. No, it's not just me. All of you have access to, where is that? Come on. Where did it go? Hello. There it is. So let's read that. it says your account, meaning including your also. Your account at Cloud Genius can use unlimited storage in the Google Drive. That part apparently is interesting because it's unlimited. And if for some reason you need more space, I can double it for you, like 2 times unlimited, something like that. That was a bad joke, by the way. I can multiply infinity by 2 to give you double infinity storage. That's the benefit that Google is giving us as educational institutions. All of us have access to unlimited Google Drive storage. And so you are welcome to use it. You are welcome to use it according to the terms and conditions laid out by the Google company. And you will receive that if you receive this email address. If you ask for it, I will give it to you. And as a consequence, you will get access to unlimited storage in Google Drive, which is kind of sort of interesting. Unlimited is a good thing to have. But then you need to decide whether you want it or not. And if you want it, I'll give it to you. That's the thing I wanted to talk about. In addition to this, there are a bunch of other services that I don't know if you're interested or not, but we have this thing called CloudGenius. What is that? Hold on, let me adjust it. Yeah, I need to type properly. CloudGenius.facebook.com. Now, this is not your regular Facebook. This is the Facebook for Workplace. So this is what the product is called, Facebook for Workplace. And being an educational institution, yes, we have access to it also for free and for perpetual use. But again, it's up to you if you want it. By the way, you automatically, if you ask for this one address, where is that? If you ask for this one account here, you get access to everything. There's no way to not get access to some things or not. So I just enable you log into this location, and then you access Office, you access G Suite, you access the storage. You have also get this OneDrive storage here. You get access to all of these services, and you get to access. So the Facebook for Workplace, I don't know what you do with it, but so I'll let you decide. Okay, moving on. So I'll erase all this, or rather move another sheet. So what I will like to talk next is the idea that we were building on the last time, which was virtual private cloud. And we began with a very simple implementation of just 2 subnets. This was called the public subnet. This was called the private subnet. And we created a machine here and one NAT device we put in here. And then we had a gateway that allowed us to connect like that. And this machine connected through that NAT device. That's what we were able to create. Simply, we had a corresponding route table, another route table here that defined that this machines in this subnet will traverse through the NAT device like that. Whereas this route table defined that the machines in this subnet can traverse through the gateway directly. And we saw some traffic. We saw access to this machine here, even though it doesn't have a public IP. No public IP, we will still be able to connect to it because we used a jump proxy command method in SSH configuration. And that's how we were able to get inside into the machine M1, and we were able to operate on it. We also remember to disable source destination check. And that is the thing that I think I want you to remember. If you're doing it manually, when you doing it in a scripted fashion, you just add a piece of code that will do it for you, so you don't have to remember it. But when you're doing the hard way, this is something that is important to remember. And that is why the NAT will then become functional like a NAT device. I need to put my microphone in the right spot. I think it is still away from me. So I'm grabbing it and putting it in the right location so you can hear properly. Sometimes I not speak loud enough, and so it doesn't pick properly. And sometimes some noise from outside can come occasionally. So that noise gets suppressed because my sound is picked up primarily because it's proximity. Okay, so this simple design that we had I want to make some of the concepts here clear for us to understand. One of those important concepts involved here are the idea of what I call firewall rules. Firewall rules or security group rules. These rules decide what can go from where to where. They're rules, right? So you apply a collection of such rules to a given use case. For example, in here, I want to run my applications. So I would like to have a set of rules that applies to my application machines. Like these guys will have a rule, a set of rules. A machine that is dedicated like a NAT device will have its own set of firewall rules. And like that, we will have other things go along. Like sometimes we will have another subnet. We will store our databases here. We'll call it our database subnet, which is different from the private subnet. It is also a private subnet, but let's rename this private subnet as my application subnet. And so this is also private, this is also private, but that is dedicated to running my application machines, application servers. This will be another data subnet, which will be hosting my database servers. That's another idea that you can think of. So in that scenario, when you have database servers running here, you need to have another set of security group rules that will control the behavior of traffic in and out of these boxes. So you have to have a separate security group corresponding to that. So what I'm just hinting at is that we just expanded our scope of the number of subnets we can have is really depending on how many types and levels of what I call tiers of architecture. Sometimes people talk about this N-tier architecture, like 2-tier architecture, 3-tier architecture. You have a public area, which is most like a DMZ area, demilitarized zone area, or then you have application area. You can sometimes have a area where you will have some, caching solutions implemented. Sometimes you might have a database location. Sometimes you have some other exotic applications. So you can have separate subnets carved out to create independent subsets of the overall network and create a multi-tier architecture. And for each of these lines that I'm drawing vertically, they're essentially a subnet. And corresponding to that subnet, you will have a route table that will define how the traffic will flow. Corresponding to that collection of the other guys, you will have possibly one or more security group rules or firewall rules. And then you also keep doing the same thing for the database machines, for the caching boxes, for the application servers. And sometimes you have what is called a load balancer, which can be some kind of a way for people to come inside and access your services. That will be something like port number 80, port number 443. This is an ingress solution where people can come into accessing your applications. Or sometimes you might have another one, another subnet. We'll call it the web servers. That can also be a possibility. There are multiple different subnets you can create. And you can have these guys independent and isolated, but be able to allow traffic according to what you dictate. Like what will be able to go from where to where. You control the traffic flow of any internet traffic within your virtual private cloud. You need to be really carefully paying attention to these things, like security group rules or firewall rules as to what can flow from where to where. So that is a simple illustration, what I just showed you, of a N-tier blueprint of something that you want to construct inside a virtual private cloud. However, something that is still missing in here. And that idea that is missing is the concept of redundancy. Or the other idea or the other concept is basically known as high availability. If you want to make sure that your entire infrastructure is highly available, you need to have 2 or more of them. So that translates to something very simple. And that is, you need to create, simply speaking, for simplicity, I will reduce the number of subnets. Just leave it to 3. This is called, I'll call this my, I think in the videos, one of the videos I use the name border checkpoint, where, border checkpoint is something that is like a demilitarized zone, DMZ, or basically public, simply speaking, public area. So that various different names for the same concept is what I've been using, but essentially they all mean the same thing. And so these 3 subnets that we have in mind, what I want to do is define a redundant setup for the same exact thing. What means I will have another public subnet, another application subnet, another DB subnet. And I will have another public subnet. And what I will need to do is that as I create a NAT machine here, I will have to have a NAT machine here also. I will have 2 routers. I will have applications machine 1, 2, 3 like that. And I will have machines 4, 5, 6 like that. I will have a database master here. And sometimes I will have a database slave here. They will be replicating. See, things of that nature. And the division or the dividing line in between here will be something that will be across fault boundaries. Now that is a term that I just thrown at you, but this idea is that think about this as a boundary of fault, meaning if a fault appears to be in this geography, then it is likely to be not caused in the other geography. Like not problem. If a problem appears here, then it is probably not there. An example of that would be in geographical terms, a river. A river on one end, there is fire for some reason, for disaster happens, some natural disaster happens. And if this line that divides the 2 areas are a river, it's a river. And then you have something going on here, for example, a fire. In this side of the river, it is likely that there will be no fire. And so you are basically trying to divide the region, the physical geography, into 2 different physical fault boundary. So this becomes your river. Similarly, there are other cases in which you can find geological fault boundaries, fault lines. You may have heard of this thing. I'm not a geologist, but what I know is that this is one example of a San Andreas fault. You can see that there is a physical deformity that is, you can read more about this thing, by the way. I'm not a geologist person, but the concept is if you happen to have a problem on one side of the line, then there is less likely to have a problem on the other side. Now, why am I saying all these things? Primarily because what I want to hint at this idea is when I go to, say, for example, one of the locations in the Amazon cloud or just any cloud, you will find that as I start to create a new VPC, and you will find as I say, create a new VPC. So I'll create one. I'll call it my Cloud Genius VPC. And by the way, I deleted the old one, so I'm doing it again. I'm assigning it a CIDR block here. And then here you will notice something different. Is that once I create that machine, once I create that VPC, which is going to be created soon, when I go to creating a subnet, and I say create a new one, and let's call it my public subnet, and I will create that in the Cloud Genius VPC, and in here I will select, say, 10.0.0. or rather 1.0/24. Let's put that number for now. So I'll use this as a reference as to what we are really selecting. So we chose at the VPC level, we selected this subset. And now at the VPC inside, we have a subnet we are creating. We are calling it our public subnet as the first public subnet by this address space. And this is your VPC address space. So I am beginning to label them according to what I have in mind, and you will see my labeling patterns a little bit. And this is up to you as to how you label and how you select them. But you will see something unique that we did not discuss the last time right now. And that was the selection of an availability zone. In the last time, I just comfortably ignored this section. And here you see that there are these zones available to us. So A, B, and C. So I can select, very consciously select, that I would like to have this particular subnet created in the 1A availability zone. And therefore, I should label it to be something like A, and then create it. So when I am doing that, what I just did is I created a subnet called public-A and gave it this range of addresses. Now I will create another one like this. And here my range will be slightly different. What I want to do is select this number. And similarly, I will create another one like this. Instead of the number 2, I will make it 3 and associate with the C availability zone. That's how you label and define the ranges of addresses within your subnet. So you can very visually tell where are you when you are selecting, looking at a machine at an IP address. You can just quickly tell whether it is in the A zone or B zone or C zone. That's how you should craft your subnets as you go and build these things. This is just one idea. Of course, it's up to you as to how you want to configure them. Now, sometimes other clouds, like for example, the Virginia cloud here, you will see that it gives you 5 different availability zones. Like for example, if I go and create a subnet and I'll say, give it a name here, and I see my availability zone selection. I say 1A, B, C, D, E, and F. Now there are 6 these days. Apparently, I thought the last time I saw it was 5. So now they've expanded the availability zones to 6 different availability zones, A through F. That is the largest cloud Amazon has is in Virginia, Northern Virginia. So I think I was operating in the California location. So I'll go back there, but I have created a public A. I can similarly create public B. Simply just typing it in the name, giving it a name, and then consciously selecting the West 1B availability zone, and then assigning an address space 10.0.20/24, and then creating it. And it says something is invalid. So let's see what is invalid. It says the value parameter availability zone invalid. Subnet can be only created in the follow. Oh, so there are sometimes issues, which is it is preventing me from creating a new subnet in the availability zone 1B. That's what it reads. If I read that carefully, that's what it's telling you, is that subnets right there. It says subnets can currently only be created in the following availability zones, which is A and C. So I cannot create a subnet in the 1B availability zone. So I should go and select the 1C availability zone, and as in conformance with my naming principles, I should change this number 2 to number 3. Like I have chosen number 2, so I should make it 3. So I'll internally rationalize my numbering scheme with my availability zone labeling, and I will know exactly what I am doing, and I should also label this as C. And so then I create. So now I have 2 public subnets, public A and public C. And I am not able to create a 1B subnet called public B, but that's okay. That sometimes Amazon doesn't let you. That's fine. It's no big deal. But just remove that from picture. we just live with 2 for now. If you want more availability, you should go to the bigger region, like what's it called? Virginia. You should go there. This is California is slightly smaller. They don't have that many availability zones exposed to my account. Probably in your account also, you'll probably get 3, A, B, and C. I am being prevented from creating a subnet in the availability zone B. So I created A and C, which is fine. Similarly, I should create another subnet for applications. And similarly, another subnet for databases. And I will label them very, very similarly. What I would like to do is I'll call this application A. And this one I like to call it database A. And then I will associate an addressing scheme that is kind of sort of similar to these guys, except what I will do is change the number a little bit, maybe make it 11, like that. And here we'll have application C, and we'll make it 13. And copy the same thing again here, and let's create a similar structure for databases. And we will create that as, say, 21, 23. So now you see the way I'm thinking about how do I go about labeling and carving out the address space that I might need for a higher availability setup, specifically compare with this 0 here, with 1 here, and the 2 here. That's, if you look at that, you can tell by the way I'm numbering that I have carved out different subnets in different availability zones, and thereby I'm able to operate and construct whatever I need in my cloud. And I'm going to create these guys quickly. So I'll just go and finish that off. What I want to do is let's create application A and use this address like that, and select in the A area and then create. And similarly, application C. And this step, I will probably skip the database again because it's too much of boring work, boring for all of you to watch and for me to do. So I'm skipping that. Application C, and locate this one in the C availability zone and make it 10.0.13.24, 0.24. So that's what I just wrote for application C. I have West 1C. And I'm selecting the CloudGenius VPC, and I create. So I just ignored these guys, but you get the idea in terms of how I go about labeling my subnets and specifying the exact address ranges. By the way, this one is not written like that. It should be written like without a 0, sorry, and without the 0. That's how you should write it. But for understanding, it's easier to understand what I'm dealing with by putting that 0 in the right spots. Having created these subnets, now you get the idea. What we are really constructing in the bigger picture is essentially putting now the next logic is to create route tables. We have to have an internet gateway, which is not there available because I deleted the whole thing the last time I created. So I don't have it anymore. I have to create that gateway and go about building that setup. So let's go finish that off, creating a gateway and create. And then we close this. We would like to associate this gateway with the attached to a VPC called CloudGenius VPC and say attach. We'll go to subnets. We have them already. We are not going to use the default subnet provided to us, so we'll leave it alone. We are to filter it down to CloudGenius VPC. We'll now focus on route tables. We already have one. We are not using the one given to us. So we'll ignore this and create our own route tables. Now, as a same logic like last time, we have to have multiple route tables. Actually, you can combine multiple route tables in just one table and associate with multiple subnets. That is also okay. But for sake of completeness, I will create independent route tables. For example, here is a public A route table and create that. And then I'll create a public C route table, pretty similar to that. Public C, and another one for application A and application C. If there are any questions at any moment, please make sure to ask them, because what I'm building is the foundation for more complex architecture for us to understand high availability scenarios and how do we construct a reliable enterprise grade application that to run in the context of a cloud. And so that's what we now are building towards. As you can see in here, I have 4 subnets, and I'm going to ignore this one, the one ignored. And then rest of these guys need to be associated with their corresponding subnets. So that's easy. We just associate the public A with public A, and then associate public C with public C, simply. It's very easy to do that piece, that easy to understand also. So associating that very, very simply. And the last 2 associations are with app A and app C. So we'll go do that piece. App A associates with app A, and app C associates with app C. Now, one of you actually the other day asked this question about, what was that? Oh, I lost my train of thought, but let's finish this. So app A and app C, they're all associated, each one of them associated with one subnet exactly, but this one is ignored, so it is not associated with any subnet, which is exactly what we want. Now for the public ones, we want to make sure that these public subnets are routed directly to the internet using the gateway that we have. So we'll select the gateway and save, and do the same thing for a public A association. So the association already there. I want to expand the route and use the gateway, and then save. So now the routing will happen for public C as well as public A subnets. But app A and app C are still limited. They are limited only within the VPC. They need a NAT device in each of these public A and public B subnets before we can come and associate these guys and create a route for them to go to anywhere on the internet using the NAT A, like that. But it doesn't exist yet, but it will pop up when I create them. And that's when you will see that a complete design builds up. There is an internet gateway that we already have associated with it. There are, I think the security group that we have is a default group that we have. So we'll mark that as do not use, or rather ignore. And we'll create our own security groups for these guys. For example, a group for NAT, a group for application to begin with. And to understand that detail again, we have to have a name for the security group. We'll call it a NAT group. And the NAT group will have NAT permissions. We'll create that and then include some set of permissions for that group. And one of the NAT rules that we would like to have is NAT should be, traffic originating from NAT should be allowed to go to the machines, the app machines. So we'll create that rule in the application servers. But for the NAT should allow inbound traffic. So, from the perspective of these rules or security groups, you should focus on inbound rules primarily, is what can come into the NAT security group. Now here, in that security group, we want to allow the machines like application machines M1, M2 that we will have in the application server subnet. We'll allow those machines to come into here, into the NAT security group. And similarly, we have to have another subnet for the applications, and that will need to be created, and we'll have to grab and allow permissions according to what we are doing right now. So for example, in the NAT group, I want to allow inbound rules. So I will edit and say that allow any traffic provided it is coming from the application machines. See, I selected what did I select? I selected the application machines. So the application security group. If I select that, it will allow traffic from applications. And then I will save this one. That's one rule, to allow all traffic coming from the applications. I will also need to have one more rule, which is to allow me to go into this setup, into the picture that I have. I want to go in. If I am here, I want to come into the NAT device. I want to go to that NAT device, but
I just, the last time I said, if you remember that, I was able to, so let me remind myself as to what did I say about NAT. If you remember, when I connected to a NAT device through SSH, the first thing I should quit this, and I'm using that notebook, not this notebook. So, okay, go back here. If you remember the last time I used a NAT connection to a NAT machine, the very first thing I did after I connect to SSH was exit. Don't do anything in the NAT device. Like, that's the very first thing I said. Basically, what I'm trying to communicate to you is that you should use these machines like NAT, for example, and any machine that you deploy. It should have ideally a single purpose, like really one purpose. And don't club multiple things together. That'll reduce a lot of hassle down the road when you build more complex things. So you very clearly define what needs to be the purpose in life for that machine. So purpose in life is something that you want to pay focus attention on. So when I connect to the NAT device, I SSH it just to test out, but then the first thing I did is exit, because it is not a machine I want to play around with. It is supposed to be functioning like a NAT machine. And I also said one thing, which is purpose in life, which you understand what it means. But what I'm more importantly saying is do one thing, do it right. That's the kind of definition you should focus on. And this thing which I just searched for is a very well-known phrase from the Unix philosophy. You may have heard of it. These guys created it. These guys are, you probably know them by the C book. So if you look at one of the philosophies of Unix, there is this thing, number 5. And it says right there, do one thing and do it well. That's how you should think about all these machines that you will create, all these applications you will build. As the more complex you will go and get to, it's easier to manage your setup, your infrastructure, your configuration, whatever you have in mind, or whatever you're building for your company, is to keep that concept limited. Every unit, the purpose in life of this NAT box, say for example, should be as small and as focused as ideally technically possible. So just let that machine do one thing and don't mix and match, don't put other things in there. You will be much better off. That's how this thing means. So do one thing, do it well. It applies to people, it applies to processes, it applies to code you write, it applies to machines you deploy, it applies to whatever you do in life. In general, it's a philosophy thing, right? It's a discussion on philosophy. It's about how Unix treats things. That's what I want to focus on, is to remember this one idea very, very clearly, is to do one thing and do it well. Now, what does that translate to in action? Now, what do I do now? Okay, I understand this. The action is, when you're deploying these machines, you want to not use them for anything else other than whatever that function is, like NAT. So you will not be entering in those machines for you to be able to jump into another machine. No, not even that is not allowed. You should disallow yourself from doing that, because it violates the philosophy, which is do one thing and do that really well. And that's what NAT will do. Just tell it to do one thing, just behave like a NAT. It will keep on behaving like a NAT, and you don't mix and match other things, other concepts into the same box. Let the box do one thing, do it well, and don't muck with it. Like, do not. If you behave like this, and if your boxes behave like this, you will have a very good, stable solution set. But now, how do I enter? Right? I just said, I still want to get to these machines, that I create here, and sometimes here. And these machine M1, M2, and there are so many of these machines I will have in my complex layout. How will I then enter there? That's another question. You just said don't use the NAT box because you are supposed to be doing one thing and do it right and don't mix. And now what? So what do I do now? So any ideas? And what do you think I should do? if I just have to, meet this concept of do one thing, do it well, what should I do? How would I solve the problem? Anybody? There are many ways to solve this problem. So just any of the other ways would be okay. But what would that be? It's very simple. I'll tell you what it is. I guess you're not in the mood of talking. It is Friday. So let's see who. I think we just have Kenny, Gustavo, Jessica, and Tina. So only 4 of you here. That's okay. Back here. So what I'm suggesting is that since I just said, you do one thing, do it well. So you let the NAT behave like NAT and don't mix other functions, other things with it. So with that, in line with that thinking, what I am saying is that you should create another box. If you want to come in and jump from here to here, or maybe here, you should just have a jump box, a dedicated box just for jumping. That's how you should do it. So just create a box. It's a tiny T2 Micro $5 a month box, a small machine, and just use it like a jumping stepping stone to get inside. That's how you should consider a dedicated box for that one purpose, for jumping. And you don't even have to spend a whole lot of money here, because what you're really doing is, once you want to jump inside and maybe examine what's going on here and things like that, then you do that examination. And when you're done doing the examination, you want to kill the box. And thereby, you're making your setup more secure. Even you cannot get inside because there is no box to jump. And so you killed the jump box itself. So next time, when you want to get in, you have to first create a jump box and then get in through the jump box inside. That's the approach I would suggest, is to not use these NAT boxes as jumping stones or stepping stones, but instead dedicate a separate box just for jumping, which translates to you creating another box in this public area, here or here. Just one is enough. You don't need to have 2 jump boxes, because there is no reason to have a higher reliability situation, because it's you jumping. There are no customers involved. So you can just start a jump box, use it to go inside and just move on, do your thing, and then move on and delete the box later on. That's how I would recommend that you do. And so in line with that thinking, let's go look at our security principles here. When I'm looking at my NAT security group, I'm looking at my inbound rules. Should I allow myself to come in through SSH? Should I allow me to come in? Like, should I put my IP here? Should I put my IP there? That's the question. So here's my IP address. Okay, come on, copy my IP address right there. Okay. So now my question is, should I, why is it not copying? Copy, please. Okay. The question is, should I put my address right there and say, allow me? Should I do that?
Into the NAT, probably not.
Yes, correct. Don't. So don't have that rule here. And so for that means I should leave this traffic only from the source, which is for my applications to get in. That's how I should leave it. But then I need to create another group. And I'll call this the jumping group. Or you can call it whatever in your native language. Like I'm just using some random words. Jumping, or let's call it jump box. That's easier. Jump box. The jump box dedicated rule that will allow me to go into, so there is this jump box rule that I just started. It is empty right now, so I'll edit it. And here I will allow myself to go in like that. Oh, no, grab my IP and then go back here. And I don't know why it's not suggesting my public IP to myself in this. It should, but it doesn't. Allow me in. And then I save. So that's how you should structure your security groups collection. So for jump box behavior, you want to allow yourself, allow me in. For NAT, you want to allow other boxes in your cloud, wherever they are, other subnets, to let them access the NAT. So that's how the design is. So we are really paying attention to every item that we put in terms of rules that we allow, carefully looking at what it should be. Similarly, we want to say that in the applications group, I would like to allow traffic if it comes from the jump box, right? Because I just selected this jump box label. And so I need to allow that jump box as a item from which traffic can come into the applications. I'm looking at the application security group and I'm saving this rule, which will allow me to actually go through the jump box and then get into the applications. Otherwise, the applications will not respond to the jump box request. And that will, very logically happen if you don't allow this security group, which is your jump box group, to get inside an inbound rule for applications. You will not be able to connect to your application machines. Similarly, you want to look at the NAT group. And if you want to connect to NAT in case of disaster, you want to be able to connect to that NAT machine. So you want to allow another rule. And you want to say that I want to get in from my jump box. So allow from jump box, like that. And here also the definition should be edited to indicate a flag, allow from jump box. Isn't that jump box address? Yes. And so I'm allowing jump box to come into the NAT, allowing jump box to come into the applications, and I'm ignoring this default security group. So now our understanding that I want to make sure is clear, and you have to evolve your security group collection of rules, collection of firewall rules according to what you have in mind in terms of the number of subnets as it grows, or the new types of application scenarios you will build in. For example, you might have in the future a database. And so that database will need its own security group. So I create that group right now, and I create it. Now, just thinking about the database, what I want to do is, in this database security group, I have no inbound rules. So what rules should I put in there? For example, if I look at this picture, and I have the databases, and I have these applications, and I have this NAT, and I have a jump box, which is not killed out yet. I will eventually kill it, but I leave the groups, the security groups intact. I have this jump box that I want to be able to use to connect. But for right now, what I have in mind is a question for you, which is, what should I put for the database security groups? What should I allow? What should I not allow? For databases, machines that are running my database here and here, I should allow them traffic coming in, provided it is originating from these boxes. My applications need to connect to the database. So I should allow that. Like this, connection like this should be allowed. And that means I should go back here and say, please allow connection And I can even specifically pinpoint and say that I would like to use some, Postgres SQL database. So I would like to allow only for the applications, allow apps to connect to DB. And I would like to limit that to only this one port and only for applications. This is the applications security group. So I'll save that. And by doing that, what I just did is allow my applications to connect to the database. Should I expand it further and allow NAT, allow all traffic coming from NAT device? Should I do that?
Probably no reason to.
There is no reason to, correct. I don't see a reason why NAT should by itself try to connect to a database. There is no reason. It should not be allowed. So we should remove that. Don't do that. That's how you think whether you should have a rule or not. It needs to make logical sense. You can even further refine these rule structures to be very, very narrow. Like, for example, this is a good idea of a narrow rule. A narrow rule is limiting a particular protocol and a particular port number 5432 for Postgres database that you might have. If you have Oracle database, you need to go select that one, which will automatically include port number 1521, which is where you will run your Oracle database on the back end. Similarly, if you're running Microsoft databases, where is that? Here, you need to open up this port. And MySQL is another database that you will use this port. So different ports, but you are basically narrowly limiting to that one port number. For your applications, only just the applications to connect to the database like that and save and have no other rule. Having no other rule makes it very narrow. And that's how you should design. In fact, I will make it even more narrow as we go discuss these other things. So for example, I just made the database very, very narrowly focused, and all it allows is access to the MySQL databases through port number 3306 coming from the applications. Okay, that's narrow enough. There is no other room where I can further shrink it and further narrow it down. I don't see how I can further shrink. So I move on to the other one, this one, jump box. The only rule I have here is a very narrow rule that allows me in my location to come in from port number 22, and that's it. That is also a very narrow rule. So I leave that one because I cannot any further shrink it. However, here there is opportunity to shrink. We can see how we can shrink it. For example, let's see what the rules we have currently. The rules we have are allow all traffic from applications. Maybe we don't want to allow all traffic. Maybe we want to limit only certain traffic. For example, allow only HTTPS traffic from apps. And similarly, in the NAT group, we don't need to have all traffic coming from jump box, but only SSH traffic, because that is going to be me coming in from jump box and trying to go to the NAT machine if I need to. And so the only protocol that should be open is that one, is SSH protocol. So I further narrow it down. There may be other cases of applications in which the applications may need more than this one port. If that is the case, you want to expand it to add another rule. Sometimes your applications may want to send out something on some other port. They want to access the NAT. So you want to expand it and say custom TCP rule and add any port number you like. Say, for example, port number 587. And coming from the applications, you want to allow SMTP traffic originating from apps. And so for that, SMTP is typically run on port number 587. So you allow that port, custom port, and allow the HTTPS traffic coming from apps, and allow 587 SMTP traffic coming from apps. And that's how you can expand your rule set. If you are not sure, and if you're testing something and it's not working, a quick workaround will be to add another rule and add all traffic for now and allow everything coming from the applications, allow all from app as another additional rule that you want to just temporarily put in place like that. And then diagnose and debug and see what's going on. And once you identify the root cause, then you disable this broad allow all rule. And you narrow it down again to exactly those specific ports that you need open. That's how you would go do for the NAT security group. Let's look at the application security group. In this application security group, what we want to be able to do is, I have said a rule which is very, very broad. I want to narrow it down again. I want to say allow SSH only from the jump box. That's all. Then I will save it. But you will know that in this picture, there are these application machines that I have that look like these M1, M2, M3, and all that. And so what I want to be able to do is have my users who are outside this VPC, for them to connect to the applications eventually. And so that will happen. But for that to happen, for people outside to be able to connect, I need some kind of a load balancer. And a load balancer is typically double or triple footed. So it has a foot here and it has a foot here also. So it sits on multiple availability zones. And it will be able to divide your work that is expected of the users are expecting. There'll be a lot more users coming in, and they will all hit a load balancer endpoint or an ingress endpoint. And that load balancer will be acting like a traffic cop. The cop will then divide the load among M1, M2, M3, M4, M5, M6. That division of labor is by default how load balancers work. They balance the load. Now, having understood that piece, you know that these people come in either on port number 80 or port number 443. So you need to have a separate security group to control the behavior of the load balancers, which we don't have. We don't have it yet. So we need to create one, and we'll have to create a load balancer security group that will take care of the load balancers in our VPC. Now that is again empty right now. So I want to make sure that this load balancer security group, which is currently empty, allows for a traffic coming from port number 80. And it should be allowed for anybody on the internet to access. Similarly, allow HTTPS traffic and allow everybody on the internet to access. Allow public to access HTTP and allow public to access HTTPS, like that. So I created these two rules which will allow public to access the load balancer, and I save that. By doing this way, we are limiting access to the load balancer only on these two ports. If you have some other exotic applications that runs on other ports, you should, of course, open it and open up those ports on the load balancer itself. Now, a traffic coming in from outside and anywhere on the internet, a user on the internet, like 0000/0, if they come to the load balancer, the load balancer needs to then interact with your machines. That means your application security group should allow traffic coming from the load balancer security group. That means you have to go back to the applications security group and expand the definition to allow traffic coming from port 80, originating from the load balancer. I just selected load balancer. Allow 80 from load balancer. And similarly, another rule, port number HTTPS, allow from the load balancer allow 443 from the load balancer. So I'm allowing 22 from Jumpbox, 80 and 443 from the load balancer, and I save. And that way I will allow this traffic to happen, this one. Now my question to you is, do you get the idea of security groups clearly as to what's going on? Do you understand this idea, first of all, clearly? Because if you don't, we have a problem. I should not move forward without it. So please tell me that you do.
I understand it.
Okay, good to know. And so what I will do now is I will build something interesting. For example, I will actually put some applications right here, like here. And we'll have a NAT, another NAT, and all that. But we don't want to unnecessarily make it so complex. We have multiple NATs. We'll do this programmatically, much easier. Doing it by hand can become a little bit boring. So I want to focus on the minimal set that will get the point across in terms of understanding how these things work from a load balancer connectivity perspective. And we want to play this from a live example. And so we will have maybe one NAT and a bunch of machines here and see how the load balancing actually works out. Have you done such a thing before in any other context? We have a load balancer in front and multiple applications running in the back end. Have you done such a thing on your own somewhere in some other context in the past? Anybody?
I work with load balancer with a real machine, not on the cloud.
Okay, fine. So real machine. So which load balancer do you currently use?
F5.
F5. So F5 networks, F5 is here, right? If you know this F5 network. This is a product which is basically a load balancer. So where is that website? Right there. So this is the Twitter account for the company. So bottom line is it's actually using under the hood HA proxy. If you look at this product, which is open source, it looks like a website created by a child, but maybe it looks like Craigslist, but it's actually a very good product, really, really good product, very high performing product and open source, and it is stable. And it is probably the foundation behind F5 networks. I think they use this product under the hood. They don't tell you about it, but that's what it is basically this company uses this product under the hood. And so does Amazon, and so does most of the companies. It's a very high quality product that gives you simple load balancers. So you can have a HA proxy load balancer in the front, and it will allow you to configure just like we are going to do right now. So we'll use a ready-made load balancer right now and use that load balancer to create that in the context of our cloud setup that we have now built up until now. So we'll expand it to build and include a load balancer and have a NAT machine, have one or two or more of these machines, and see how they will balance the load in the context of our cloud setup. So that's what we will be doing in a live setup, in a live exercise. So we'll go do that. We'll begin with creating these NAT machines, and then machines to run some applications right there on the back end. And then have this load balancer, configure it according to what we want. So let's go do that. We'll go here and look at, in the case of cloud, we'll look at what we have. We have our EC2 setup where we can go and create a load balancer. So we will identify load balancer and create one. In this example, you will see that we have to create a load balancer that can handle HTTP and HTTPS. So that's the one we will select. And then it will be internet facing. We'll give it a name. This will be called my load balancer. And it will be internet facing. It will operate on the HTTP protocol. We can also add another protocol later on, but not right now, because HTTPS requires a certificate and I don't have one ready yet. So we'll talk about certificates later on. But for right now, I want to make sure that the port number 80 listener HTTP is the protocol I will be using as my load balancer protocol, port number HTTP protocol on port 80. I will select a bunch of availability zones in the CloudGenius VPC. In there, I have two subnets already available. I have a West 1A and 1C. So those two selections that I have, I want to make sure that my load balancer is going to sit on the public subnet in A and public subnet in C. That's what I'm selecting. So I've selected those two subnets as the subnets of my choice for the load balancer. It is internet facing, port 80, and these two availability zones, A1A and 1C. And I have two public subnets, public A and public C. That's what I'm selecting, and I'm proceeding to configure my security settings. Now, in this example, it is saying that if you improve your load balancer security, your load balancer is not using any secure listener. That's okay. If your traffic to the load balancer needs to be secure, use the HTTPS protocol for your front end configuration. We can do that later. Not necessarily need to do that right now because we need certificates and all that. It complicates setup without the benefit of increased understanding. So I'm skipping that piece. What I would like to do next is to select our security group, which we have already configured. We have configured a security group called load balancer. And so I want to just select that because that is exactly how we would like it to be. And we will examine the security group itself, but I'm just selecting that one, which is designed to be used with the load balancer. And so I'm just selecting that existing group and I configure my routing now. So I'm selecting a new target group, which will have a name, and it will target the HTTP protocol, port number 80, and it will target an instance on the back end. So there will be an instance that I'll have. The machines that I'm going to talk about to create these M1, M2, M3 are instances in Amazon's language. They call them instance or instances. They're boxes, basically, or virtual machines to be specific. And so the target group is going to be having a name called target group. And in there, it will target the HTTP port number 80 on the instance targets. I will then register these targets, which I currently have none. So I don't have any instances running, which means I will have to register them later on. For right now, I think I can proceed forward without any instances. So I don't have any machines running yet. That's okay. Or maybe I want to go and actually create the machines first. So I'll go here and go to the EC2. And then here I will create, launch an instance. I'll launch an Ubuntu machine. I'll put this Ubuntu machine in my CloudGenius VPC, and I put that in the applications A. And I will not get a public IP, so I disable it. And then I'll add some storage. And I'll then add some tags, and I'll configure my security groups. And the security group I want to select is the existing one called applications. And then I review and launch, and I review this to launch my workstation key, and I proceed forward. Next, I will create another instance. This instance will be created again using Ubuntu machines in 82 micro setup and in the CloudGenius VPC in the availability zone applications C this time, and I will not receive a public IP. And then I add some storage and add some tags and add security groups, and our security groups I will choose is the application security group. Then I review and launch, and I launch that machine. And now I have two machines running. Now I'll go back here into the load balancer creation step. I go one step back a little bit, and then go forward and see if I get my machines there. So I see that this machine is running right now. So I can add it to the register target, and I'm waiting for another machine to pop up. So that will happen in a moment. So I go back to the previous step, and I previous one more, and then go forward. and forward again, and I should see my second running instance. So I'll select both of them and add it to the register targets. So now I have 2 register targets, 1 and 2. Both of them are running. That's nice. And I will use them to balance the load. Then I review. I review that my load balancer is internet facing HTTP protocol IPv4. It is in the public C subnet. It also has a public A subnet. It's a double-footed setup. As you probably saw me see at the initiation, and when I created it, I chose my public A as well as public C. Both subnets were selected. Then I configure security groups, routing, targets, 2 machines running, review. And this is not showing you C. There it is. So it's A and C, both are the subnets. There is a security group which is corresponding to the load balancer security group. I have a target definition which will be targeting HTTP protocols, and then identify whether those instances are responding or not. And then the 2 machines are, this is one and this is another. Those 2 machines will be created together in form of a load balancer target, which means this load balancer will act as the front end and will actually manage. Let's go clean up the picture a little bit. And I will have the machine M1 here and a machine M2 in another subnet, like here. This will be M2. And what I'm doing is this load balancer is going to balance this M1 and M2. That's the configuration I'm laying out right now, so that my users can access port number 80 here. And so when I create that load balancer, that's what you will see created. It successfully got created and it is currently provisioning. You will see that the load balancer will immediately in a few moments show you that it is active. And you can see the listeners there. You can see monitoring and other details as you go along. It will actually, once the provisioning completes, you will see these target groups showing you those 2 targets that you have, and they are in an initial stage. They will show as active as soon as those 2 machines respond. You will see that they are indeed responding to whatever the load balancer is asking them to do. Having created the load balancer and these 2 machines on the back end, let's also create our NAT machine. We don't need a double NAT right now, or rather 2 NATs right now. We can just do with 1 because that is not a critical high availability demonstration I want to go with. So I will say I just get 1 NAT machine. Yes.
For the load balancing, do they have option that you can specify you always want round robin or you want to have a sticky session? Do we have the option?
I missed the word option. Option for what?
Round robin.
Round robin. Okay. Yeah.
Or sometimes you can specify you want to be sticky.
Yes, stickiness. Yes,
yeah.
They have
option. Yeah.
Yes. So we'll show the stickiness option. We'll also see the round robin and other policies in terms of how the load should be distributed. That is available. Correct. It's the classic HA proxy methods. So like whatever HA proxy does, it'll do the same thing. And so you have this Amazon NAT machine that I'm going to look for. And I see that I have this NAT machine that I want to use, which is the latest NAT. I'll say, okay, you NAT, please get created. And a T2 micro NAT in the instance detail, I would like to put you in the CloudGenius VPC in the public A subnet, and I would like to get a public IP. And then I add some storage, make it SSD, and then add some tags and add security groups. And then I select my existing group that I have already for NAT, and then I review and launch, and then launch the machine. Similarly, I will now create another machine for me to jump in. So I'll have to launch another instance. This will be my jump machine. So I'll create a jump box, T2 micro jump box. I'll put this jump box again in the CloudGenius VPC in the public C side. and get a public IP address. So that is enabled. Public C has my jump box. I'll add some storage, add some tags, and configure security groups. Select my jump box security group and review and launch, and I launch this machine. So now I have 4 machines running. Those machines are, I have a jump box running here. I don't have a NAT here. I have this NAT running, and I have M1 running, M2 running, and I have a load balancer running. What I just did is created this NAT. But that NAT will not function like a NAT unless I disable source destination checks. So I have to go there and identify that running instance called NAT. And I don't know which one is NAT. So that's a difficult one because I did not label them. So how do you do now? You look at your IP addresses, the private IP. They will immediately tell you what is what, because you know your numbering scheme very well, like this. You know that if the numbering scheme is in this subnet, it is a public A. So you can very easily tell that. And so I want to find out which one is which. So I have these 2 machines have a public IP right there. So I'll say one of them. Let's go stick to this one, the last one in the list. And that is currently initializing. Looks like it is the jump box because the security group's actually giving the clue right there. So I should quickly label it like jump box before I lose track of it. So that security group is a giveaway right there. Another way to identify the same thing is look at my private IP address, 10.03.167. 10.03 is basically in this public C subnet. And I remember I created what? The jump box in public C, right? You remember? So this jump box in public C here. And so this is public A, this is public C. So I created my jump box in public C. So I know that is jump box indeed. So I'll go back here and confirm that it is indeed jump box. Let's look at this machine. It obviously has to be the NAT machine. It has a public IP address right there. So this is the NAT machine. You can tell by security group and also by the fact that the Amazon AMI ID is a NAT AMI ID. You can see the name itself tells you it is NAT. So that way you can tell it is the NAT machine. Now the other part is hard, which is to tell whether this is M1 or M2. I don't know. Does it matter? No, not really. It doesn't matter. You can call any one of them as M1 and M2. It doesn't really matter whether you call this one as M1 or this one as M2. It doesn't matter, really. Practically doesn't. Who cares? Who cares? So, but we can still go and really precisely identify whether this should be labeled as M1, depending on if it is A, or M2, whether it is application C subnet. If this subnet is A, I want to label it as M1. You can very easily tell this by looking at the private IP address of this guy. And so let's find out. App A, private IP addresses should be in this range. App A is 11.0. Okay, that means we have to go identify one of these guys. You, what is your private IP? 13. That means you are the C. You can also see the availability zone 1C right there. And it is the application security group in 1C is an indicator. Therefore, I am going to label this machine as M2. And then back here, I will label this as obviously M1. So now I have 4 machines and I need to make sure that the NAT machine correctly functions like NAT. Currently, it doesn't. You know, the source destination check is enforced. It is true. So I want to disable it only for the NAT machine. So that NAT instance action instance state, and I want to networking change source destination checks. This is where it's hiding in the networking section. Source destination check, and I want to disable it only for the NAT machine. So disable. That disabling happened. I will go back to my VPC in here, go to my route tables and look at my CloudGenius VPC and focus on the application A, route, edit, add another route, go to anywhere on the internet through the NAT device that I have and save. Same thing again for application C. Edit, add another route, go anywhere on the internet, provided you go through the NAT machine and save. Now we are kind of sort of in a good shape, at least as far as traffic is concerned. So we'll go and test it. Did we actually do what we thought we would be doing? Does it work? Does the traffic flow? Does the load balancing actually work? Can I traverse like a administrator? Can I go in using the jump box, go inside to M1, go inside to M2, go examine my NAT? Can I do these things? Can I update my boxes, M1, M2? Can I do that? Can I test my load balancer, see if it works? Can I evaluate and verify whether the load balancer is working or not? Can I examine its stickiness policy? And all those things. I want to test these things out by doing it for real. And so let's do it. So to begin doing that, I need to start my virtual machine. And so I'm starting it because that's where my key is sitting. And so it is currently powered off. So I'll power it on and I will then log in. I'll have to configure my config file a little bit. You know that config file, SSH config, I had to edit that because the IP addresses are new. My jump box IP has a different IP address. Similarly, where is that? The EC2 console will show me the IP address of the jump box right there. And so here is my jump box and it has an IP address of that. So I'll copy it and use that inside my SSH configuration showing up here. And so I'll open my command line, go to the SSH folder and look at that configuration I know, which is this SSH config. I want to edit that configuration and make some changes to it. A couple of changes I want to make are actually about making sure that I change the host name. Let me quit from here. It's easier to do it in Atom. So Atom, I'm opening up Atom, and there what I want to do is look at that SSH configuration one more time. Here I'm looking at my NAT machine. The NAT machine is not called NAT anymore. So in two places, I'll just label it differently. I'll call it jump box. Next, I want to change the IP address right here. And that is the IP address of the jump box. So I'll select the new one, which is I have in my buffer, and I paste it. Next thing, I know my jump box is not an Amazon machine. It is an Ubuntu machine. So the username has to change. It is not an Amazon Linux. It is Ubuntu Linux. So according to Ubuntu documentation, the username has to be Ubuntu. So I save it. Similarly, the machines inside M1 and M2, these guys have a range of addresses like 10, 0, 13 something. And these guys have a range of 10, 0, 11 or something. Right? So I need to grab that IP address range like here, for example, and put that right there. 10, 0, 11 star. And similarly, another one. What I will do is expand this definition to include one more collection, just like that, and make it 10, 0, 13. That way. That way I know I can go to my application servers in app A as well as in app C, because I called out the entire subnet A and the subnet C for applications. And now my jump box is already labeled correctly, like this and like that. And also my IP address is correct. My asterisk is indicator of the fact that I can access the entire subnet, whatever the IP address is inside, I don't care. So with that understood, I would like to save this file and quit Atom Editor. Now back here, what I want to do now is attempt to, first of all, list out what we have here. Okay, private and public key and configuration. So what I want to do now is see if we can connect to the M1. What's the IP address of M1? We'll find out. Where is M1? Here. We are on M1. The IP address is that. So I copied it. Bring it here and say SSH. Connect, please. So it says, okay, I'm going to connect to the jump box, and then I'm going to connect to the machine inside, and then it connected. So that's the machine running your M1. I want to make sure that I can traverse the internet, so I can ping something like ping Cloud Genius. Can I ping? Apparently it succeeds because traffic is flowing properly already, right? Next one, can I update my machines? Apt update. Maybe sudo is needed, so sudo apt update. And so it's updating correctly. Nice. What I want to do now, since I updated the apt cache, I want to install something on this M1. What I want to really install on this M1 machine is some kind of a web server. So I can see what is showing up in this box. This is the M1 box. And on that box, what I want to do is install Apache. So it is installing Apache right now. Nice. This is going to be M1 machine showing me Apache default page for right now. We can, of course, run our own applications later on. But since we want to quickly test out things, I'm just throwing some application right there. So it did. That's good. Now I come out of that machine called M1. Now I want to connect to the other machine, SSH, M2. What is M2's IP address? It is this IP address. I copy it. I go there, connect to it. And it's asking me the second question. Should I go to connect to M2? Because M2, it knows jump box already now in the known host file. But this IP address is a new one. So we'll say yes. So it connects. Now I see that I can connect to sudo apt update comfortably. And now I want to install a different looking web server just to distinguish from M1 and M2. I want to do something different here. This is our M2 machine. And so what I want to do is in the M2 box, I want to install another different looking web server. I'll install Nginx. So it will have Nginx installed. So it is doing that right now. And as soon as these things come up and running, what will happen is that load balancer we have put in place. By the way, the thing succeeded. Yeah, so I want to exit out of there. And now I will connect to the NAT box just to make sure that the connection is successful. And then here's the NAT IP address, this is the public one. I would like to go from within. So I want to, if I try to go to that IP address directly, what do you think will happen? Let's say if I am here and say SSH and EC2 user at, that's the username, and try to go to the public facing IP address of the NAT box, what do you think will happen? If I go to the public IP address and try to connect using the correct username for Amazon Linux, what do you think will happen?
Would it fail?
It should fail, right? Because see, our traffic is allowed SSH only when it comes from Jumpbox, and doesn't allow me to go directly to the NAT box. So here it is. Let's see if it fails or not. Okay. See what happens. Nothing. Nothing will happen. It will not work. I know I created the machine. I know the username is correct. I know I have my private key in good shape and all that, but nothing. That's exactly how it should be. Is NAT should function like NAT. Jumpbox should function like Jumpbox. Application should function like application. And everything that you do in life should be do one thing and do it really well. That's how you should think. And I think that's a general purpose statement I just made. It's not applies to computer science. It applies to human life in general. If you do one thing, do it really well, you will succeed. Even no doubt about that. You will succeed. And that's how you should also think yourself, in whatever you do, like do one thing. And by conscious design and conscious choice, it also means to say no to other things. Like I will do one thing, that means I will not do anything else. This means specialize in life, do one thing really well. And that's when success happens, when you do one thing, because you are able to focus entire energy into that one thing, that you grow immediately. And out of beyond imagination, you excel in doing that one thing. And because you're not paying attention to everything else, like you're ignoring everything else in life, that is when success happens. That was a philosophical statement, and I'm done with it. So back to computing. So you saw it did not work, because that's how it's supposed to be. NAT is not supposed to be used like a jump box. So don't allow that. Security groups prevent that. Firewall rules prevent that. And therefore, too bad, cannot connect. And so we still want to connect to the NAT. So we'll go to the dashboard. We'll go to the IP address, the internal IP address of the NAT box, and we'll connect to it from inside. That should work, because we are going through the jump box. As you can see, in my known host file, I have an entry for the jump box. I have an entry for the M1 and one for M2. But what I don't have is an entry for our NAT. So we will connect to the NAT device. The challenge here is going to be a username specified. And there is no route in our config file. If you know that we have to call out that route in our configuration for SSH, we don't have a 10.0.1 configuration, because I did not include it. So I had to expand that definition one more time. And we have to say that out loud clear in here for the 10.0.1 set, like this. I would like to have one more for the NAT access. So hold on, I think I made a typing mistake. So typing mistake, correcting that. Let's go copy this segment and put it all the way at the bottom, and then paste it. Make sure that I am editing the IP address correctly. And I'm going to say this is 10.10.01. And the username is EC2-user, and save. Now this will work. Without this, it will not know what to do with 10.0.1 or whatever. That configuration would be unclear to it. So I will now come out of it, close Atom, bring back here, and attempt to connect to SSH, that IP address. Oh, what did I type? Cancel. SSH 10.0.1.2.10, and see what happens. It says, should I connect? And I say yes. And so it connected. It connected to the Amazon Linux AMI, which is our NAT box. And since we successfully connected, we should just come out of it. Let NAT behave like a NAT machine. Out. Now, as a consequence, we now have 4 known hosts, the jump box, M1, M2, and NAT machine.
Nilesh,
Yes.
when you get a chance, could we take a quick break?
Break is right now.
Thank you.
Okay. Yeah. Break time.
Oh. Mhm. You guys just checking if you're back. And we should proceed. Okay, looks like you're back. So let's check whether our machines are responding to the load balancer. What we'll do is I'll look at our load balancer and identify if that one is receiving responses from our 4 running instances we have, actually 2 of them, M2 and M1, they will be responding to the load balancer. And so if you look at the load balancer itself, it has given us a DNS name. And it has a target group. And the target group is pointing at 2 different targets. They are both showing healthy, right there. And that health status we'll discuss a little bit later. But what you will see is that currently what we have is a configuration in which our load balancer is balancing load among these 2 machines, M1 and M2. Let's look at the picture again and see what is going on. What we are looking at is the load balancer looking at 2 different machines, M1, M2, and this one is apparently running Apache. This one is running Nginx, which is just, I want to make the perspective clear on the fact that we are hitting 2 different machines through one load balancer. When people like you and me will visit the load balancer, that endpoint, you will either see this one or you will see Apache. You will see one of the 2. By default, it will not give you both unless the stickiness is disabled. So we'll look at the stickiness characteristics also and see what's going on. I would like to give you the IP address of this point. The load balancer has given us a front end, a DNS name. So I'll pass that DNS name to you in Slack chat. Here, the DNS name is, I'm going to copy it, pass it to you in Slack, so you have it. And here is the DNS name coming in, right there. So I would like you to hit it. I'll also hit it, see what happens. I see the Ubuntu default page showing up. And I will refresh my browser again. And I see Nginx showing up. And I refresh my browser again, and again, and again, and again, and again, and again, and again. And look like I am consistently getting Apache 2. But I did get Nginx for a little bit, and then it got stuck and settled with Ubuntu. Now I get Nginx again. This may be happening because of probabilistic reasons. All of us, I'm suspecting that you are also hitting the same endpoint right now. That's what I'm suspecting, which is expected because I gave you the link. So what is happening is by way of probabilistic nature, your browser is either showing you this or that. And if you keep hitting the website again and again and keep refreshing on this page that I gave you on this load balancer, it is basically doing a round robin. It's a flip-flop between this and this, this and this, goes on and on like that. 50% of traffic will, probabilistic traffic will go here, and 50% of probabilistic traffic will be sent to Nginx, to the M2 machine. That's why you see what you see. So if you hit on this page again and again, like I saw Nginx, now I see Ubuntu, default Apache page. Now I see Apache again. What do you see when you see the
website, when you see the endpoint, what do you see?
I only see Apache.
What about repeated refreshes?
I only see Apache as well.
I was able to get both.
Try that.
Which browser do you use?
It doesn't matter. Browser doesn't matter.
No, I thought Firefox will have a new session every time. It looks like it's not sticky.
No, it is not sticky. No, it's not sticky.
It's not sticky.
No, not sticky. It'll go to Nginx and Apache, and it'll jump around like that. It is expected to jump. It is not sticky. So we will make it sticky. We'll understand how do you make sticky, and for that we'll have to identify the listener. And I think there is a stickiness built in somewhere. But before we get to the stickiness discussion, I want to make sure that we understand the ability of this load balancer as to what we have right now before we talk stickiness. The concept essentially is a 50% probabilistic division of work in these two machines. That's what you are noticing. A couple of things I would like to do is I will actually go look at Firefox browser. And in there, I will open up the console and clear out everything that I have. So preferences, and clear out all the cache. So clear history, clear now, clear the data that I have, clear that, and clear everything out. And what I want to make sure is that I have completely cleared out every single thing that my browser knows. Now, having done this part, what I would like to grab is that link. And I would like to hit that link in the Firefox browser. I'll grab that link from here and take it to Firefox. And in there, I will open Firefox browser with the same link. And I get Apache default page. Okay. Now what I would like to do is go to the preferences in Firefox and identify what cookies do I have. Apparently, I do have cookies. So let's go see what cookies do I currently have. So if I go and where are the cookies identification? I want to actually identify the cookies that I have. So I think this is changing. Manage data. Okay. So you notice that there is no cookie in my browser. That is the reason why you see that it is jumping from one to other, and then again to other, and sometimes back to Nginx. That is happening. It is happening because there is no cookie that is ensuring stickiness. The cookie section in my browser is empty, as you saw here. Manage cookie data, empty. Now, I want to introduce the idea of stickiness. Now, stickiness can be managed for a variety of reasons. Why stickiness is important, let's go look at that. So the simple idea is that I want to make sure that my visitors are always hitting through the load balancer. If this person comes, I want to make sure that this person receives a cookie in return. And that cookie is stored in the browser. The machine has to generate a cookie, and it can be stored in the user's browser. That cookie called C. That cookie can be generated at two different places. One method of cookie generation happens at the application level. And that cookie gets created at the application, manages itself, and then it passes on through the load balancer to the user's browser. That's one approach to managing cookies. By handling cookies this way, what happens is you are now able to ensure that the user who visited this machine was allocated to this machine, for example. When they come back again next time, they will go to the same machine again and again. And that thereby, they don't have to log in again. They will preserve their sessions
and they will have access to basically the same experience that like before. Whereas if you don't have a cookie, it is likely that the load balancer can dump you in another box. And therefore, you will see Apache and Nginx and toggling in between them, like I saw here. Like some of you also saw the same thing. You open up that link and you see Ubuntu, and then you see Nginx. That toggling might happen to you, and that is happening because of the fact that there is no cookie here. No cookie was generated from the application, and no cookie was generated by the load balancer either. Cookies can be generated in two different places, as I said. The load balancer can generate a cookie for you, or you can generate your own cookies in the application itself, and thereby deciding the behavior of the application. So let's see how an application, for application to generate a cookie, we have to actually write some code. For a load balancer to generate cookie, it should be easy. So let's go see how Amazon's load balancer does it. So we'll have to go and identify the approach to enforce cookie stickiness in Elastic Load Balancer from Amazon. So we'll go find out that thing. Where is that though? So where is my load balancer? This one, I want to go look at description and then edit its attributes and see if I have a delete protection. No, not here. I have to find out where exactly the stickiness settings is, because most of the time I have my applications deal with it. So I write code for that. So it will generate a cookie and put that, but I have to hunt down the exact location that this load balancer will actually create a cookie for us. So where is that setting is what I'm trying to find. Cannot find it here. Is it here? No. Is it here? No. So it should be in the target groups, I guess. In the target groups, we have description, edit attributes, and there it is, right there. You can see that. If you enable the stickiness, you will see the behavior change. And so let's go, first of all, understand where it was. In the load balancer, there is no such setting. It can be found in the target groups section, where in the basic description of the target group itself, you will find an attribute. And one of the attributes is stickiness, which is disabled by default. So if you now go and edit that attribute and enable stickiness for a duration of, say, a certain amount of time, let's call it 300 seconds, for example. So any value between 1 second and 7 days, you can select any value. So I'm just selecting a 5-minute time period for stickiness of the cookie, and I save that setting. Now I have an enabled load balancer based stickiness for a timeout period of 5 minutes. What does that do for me? Let's go see here. I am going to hit this site one more time. And I see I get Nginx. Okay. Now I'm going to hit it again and again and again and again and again. No matter for the next 5 minutes, I will be stuck with Nginx. And you see that I'm stuck. And by the way, most of you, I mean, all of you are also stuck with whatever you currently have. If you had, the thing that loaded up, if it loaded up Apache, then you are stuck with Apache. If you loaded Nginx, then you're stuck with Nginx. It is sticking because I enabled stickiness in the load balancer. What does it actually do under the covers in our browsers? So let's go see that piece. Go to the browser settings. And now examine what cookies do we have. So go look at manage data, and you still don't see cookies because I have to do it refresh again. I think I should see a cookie. I'm expecting to see a cookie generated by the load balancer. So I'll go to my settings again, preferences, privacy, and manage data. And there is my cookie. I am going to examine it. And it shows me that there's a one cookie available to me by, how do I expand it? No, it doesn't show me the details. I want to read, I think it is the same load balancer IP address, DNS name. Yes, it's the same. So it's coming from the same site.
it is one cookie, and it was last used at this time, like 4/6, which is today at 6:02. So if I wait for 4 more minutes, I will see the possibility of this site changing on me. If I keep on refreshing, it is not going to go away from Nginx because I am stuck to M2. What do you see on your end? Are you stuck also? You should be stuck to one site. Are you stuck? Anybody was trying? Oh, you lost me already.
Yeah, I'm stuck in Apache.
Stuck in Apache. Okay. So let's go back and change the stickiness settings one more time and remove the stickiness attributes. Right there. I removed it and save. Now go back browser and remove that cookie. By the way, that cookie is kind of invalid. That cookie is irrelevant. So I'll remove that cookie. See changes. Here. And now I'll go back to the website and load it again. And I see Apache. And I see Nginx. And I see Apache. And I see Nginx. And I see toggling happening. Right there, there, there. It is toggling. It is expected to toggle because I removed stickiness. So that's the concept of load balancer level stickiness as opposed to application level stickiness. Application level stickiness gives you more control because you can dictate and decide what's going on. So this is a possibility you could use, but I prefer the application level cookie generation, which you control in your applications. And that's why this setting is disabled by default, because most people actually prefer applications to control sessions and cookie settings. Okay, next about round robin and other policies that are applicable to load balancers. So you can see there are many such approaches you can take. And I think depending on the cloud company and the load balancer in question, whether Amazon Elastic Load Balancer, round robin, weighted round robin, or DNS round robin, a variety of ways of distributing the load. And that is defined in the documentation. You can tweak it. You can make changes to it depending on what you like to have. It's really up to you. So you can read the docs and how do you want to implement. But the simplest concept of a round robin, as you probably understand already, is a simple 50% probabilistic toggle between two machines. If you have more machines like M1, M2, M3, it'll do a third traffic going to M1, 1/3 traffic to M2, and 1/3 traffic to M3. That's how it will simply distribute the load like a round robin, like a circle. So M1, M2, M3, M4, M5, 6. You can just see that the work will be distributed like this in a round fashion. If you add more, it will go there. If you remove, for example, if you say remove this machine right there, then the work will not be sent there. That's obvious. If you remove this machine, then the work will not be allocated to that machine. That is expected. Let's go see that scenario. If I now go back here and go to my target dashboard, and one of the two targets I have is M2 and M1. If I decide that I want to kill one of those boxes, it's fairly easy. I just go to M1 and I say terminate this machine. So M1 is dead, almost. And there it goes, killed. M1 is dead. So let's go see now what's going on with the load balancer. Load balancer will have no other way but to send all the traffic in the target group to the target, which is currently, there's only one, it's M2, because M1 is dead. Now, in the case of M2, if you look at this machine, and if you have that IP address, if you now open up that same website here again and again, all you will see is Nginx, because the Apache server is killed, it is dead. So all you see, even without stickiness, is this thing, Nginx. Now, if you go to that machine internally and try to connect to it, like for example, SSH, and then this IP address, which is the M2 IP address, you are going to connect to it. And here is your Nginx running. You can see it. Typed it wrong. And so here is Nginx running. What I want to do is stop Nginx. So I'll stop the Nginx process simply by saying, where is the master process 11863 and 11864. So I kill both them. Now we don't have any Nginx process running. There is a worker process. Let's go kill that one also. So killing that one, 12005, kill. And how many do we have still? Still running?
You're missing the 863.
Oh.
You have 864 typed twice.
Okay, now everything is dead. Okay, so now here you will see back in this load balancer target group that this machine was apparently healthy. At least it thinks it is healthy. But if you go look at this site, it's not going to show you anything. It's a bad gateway because it doesn't know what to do because the server is not responding. I killed Nginx. So this load balancer target group will eventually catch this thing as unhealthy. So this flag currently is passing a health check, but soon it will start failing the health check. This health check is defined right here. And that basically looks at HTTP protocol on the path called slash, meaning the basic main path of the website, which is the IP address slash. That's where it will look at the port number 80 for HTTP port and see if the machine is healthy or not. So that's what these things mean. Let's go read and understand what these things mean. There's a healthy threshold, there is an unhealthy threshold, there is a timeout, there is an interval, and the success code you will expect. When you have a successful attempt, you will receive a 200 OK code back. That's an HTTP code that you expect to see. That's the success code defined. The interval, this is the approximate amount of time between health checks. How frequently will you be running a health check? Every 30 seconds. Timeout is the amount of time in which there is no response, means there is a failed check. So it will time out after 5 seconds. If it attempts to check and it doesn't get a response within 5 seconds, it will time out. The unhealthy threshold is the number of consecutive health checks required as bad before you call a machine as unhealthy. That's 2. So 2 attempts, 2 consecutive failures, it will then be called as bad. And here is a healthy machine. The sign of a healthy machine is the number of consecutive attempts you need. How many times? 5 attempts of consecutive successful responses that says, yes, I'm working, 5 times successfully. And then it will be considered as a good machine, a healthy machine. So right now, this target should be showing as unhealthy because the timeouts happened, the interval happened actually, 30 seconds happened, and then it tried a check for health by HTTP port on the slash path, and it found that there is no response, and therefore it tried it again, and there were 2 consecutive unhealthy threshold hit, and therefore this was marked as unhealthy, simply. Now if you go back here into that machine and start the Nginx process again, it will come back online. That is expected. If you bring the service up and running, it will work just fine. However, you can change this game a little bit. For example, I want to completely remove Nginx from here. Did I type something wrong or what? I have to get uninstall Nginx. Unable to resolve. What? Oh, typing mistake. It is remove. The command is remove. I forgot about that. So then I remove sudo apt auto remove and completely eradicate the existence of Nginx from this machine. And then I will install Apache on the same box. And this will start Apache server, and you can see Apache is running. As a consequence, in the next few seconds, health check starts to pass. You see Apache is running there. So now we go back here, and you see that Apache is already showing up. That means health check seems to have quickly passed already. So let's go see if this is showing unhealthy right now. Let me refresh the browser. It should show us healthy already. If not, targets, they're still showing unhealthy, but it seems to be working. You know, there's a mathematical reason why it's showing unhealthy, because the conditions haven't met, but the traffic seems to be flowing through. And so it is allowing the traffic to flow to that box, and it is now showing you Ubuntu default Apache page. And because this server is running, so it is working, but it doesn't know that it is healthy, because the definition of health check is that it has to have 5 consecutive health checks have to pass. So in a matter of few attempts, after every 30 seconds or so, you will find that the health check threshold of 5 count will pass. And as a consequence, this target will become healthy. And that's when it, you know, it's already working, by the way. So it should work all along, because actually it is healthy. It just doesn't know to mark it as healthy yet. So this is what we did from a perspective of a load balancer and 2 different availability zones, 2 different subnets, putting a NAT device like that in one of the subnets. And ideally, you should have 2 NATs. So from a high availability perspective, like here, we discussed this already. And we'd like to have 1 more NAT here. And, you know, make sure that you allow traffic like this, and from traffic from here like that, and also direct and direct. So it's a mesh that you need to create. Simply speaking, you should design your NAT structure. So this is NAT A, this is NAT B, this is your machine 1 or machine 2 in application A subnet and application C subnet. And so these machines that we created, you need to allow traffic to flow like this and out, and like this and out, and like this and out, and like this and out. That way you will have a higher availability NAT setup. This is exactly what you receive when you set up the NAT gateway, which I did not use, by the way. When you go to VPC and you set up this NAT gateway, that's what you receive, by the way, a double NAT high available NAT configuration by default. If you configure it that way, that will cost you money, but that's what they just readily do it for you. You can configure it yourself. Like I have a machine here, I have a machine here, and configure that to make it work like that. You can also put rules to test whether these machines are active or not. Before you ask for this machine to go send traffic here, you should check, have some kind of a health check in place, whether this machine is active or not. And if that machine goes out of service for some reason, you should notify these machines in application A to route your traffic like this, and then go out. And in the meanwhile, you can come back and have this one fixed through automation. By the way, everything we'll do is going to be through automation. Right now, I'm just doing it nuts and bolts by hand, but we'll get through automation as we go along. So remember that you have multiple of everything, multiple NATs, multiple subnets, multiple availability zones, and you are crafting your infrastructure for higher availability. That's how you should think out from a network, or rather bigger picture architecture perspective. That's how you should think as you go along. Okay, now I will shut down the machines I have, because I think we are done with that exercise. So I'll go shut that down, and rather before I shut them down, I want to ask you if you have any specific ideas in mind to run live exercises with, so I can play them, or otherwise I'll just shut them down. That's my plan. So I'll do the next ideas subsequent to this. So any questions, comments, or ideas to do with these before I terminate them? Kill them?
Nothing on my side.
Okay, going on. So they're dead. They're dead. Now all the machines dead. You can leave the entire underlying VPC and all the subnets and route tables and everything else. Okay, but kill the machines and also kill the load balancer. These things generate a bill. So you want to kill the load balancer just like that. You don't want to have a running load balancer if you're not using it because it costs you money. Target group, you can delete that. So that's gone, target group gone, load balancer gone. Your machines should be dead. They're getting killed right now. And that's where you should also have these volumes also will die eventually. They will soon die. As soon as the machines die, the volume will also be 0. And you can leave the security groups just like you have in mind, just like we created. It doesn't generate a bill. So that's what I'm trying to highlight to you is machines, you kill them as soon as you're done. Load balancers, kill them after you're done. But VPC itself doesn't cost you a thing. If you have a NAT gateway, you should kill it. If you have a simple gateway, leave it alone, no problem. If you have a series of security groups like this, leave them alone. If you have all these other things that we saw in the VPC section, you can just leave them alone. There's no reason to delete them. Although I seem to delete them quite a bit, but doesn't matter. I do it for clarity, for you to understand. If I have too many things going on, it will muddy the water. So I clean up sometimes and I reduce the complexity for us to really understand what's going on. So you can leave the route tables intact, no problem. Internet gateway, you can leave that alone. Egress only gateway, that's also okay to leave. This is only for outbound traffic. So you cannot come inside from this gateway. So that's something that is a specific use, egress only. So your machines can go out using this, but no traffic can come in. If you want to use such a setup, that is a possible option available only in Amazon Cloud. We have Elastic IP, sometimes we receive them. It's a good idea when you're deploying a production setup that you want to allocate an Elastic IP. And you can just allocate, like click the allocate button, it will give you one. Now the name Elastic IP is something that I do not like, but it's not my company. So I just live with it. But the actual name is Static IP. That's the right name to use. It is the branding that Amazon has is the idea of Elastic everything, Elastic Cloud, Elastic this, Elastic whatever. So that's the naming, but actually this is a static IP that you receive. To me, Elastic means flexible. And yes, it is flexible in a sense that you can take an IP from one machine and connect to another machine. That's a possible reason why they may have called it Elastic, but actually the IP number itself is a static number, and that's what you receive. And that costs money. So you want to make sure that you don't waste money if you allocate an address like that. You want to release the IP address that you get. Otherwise they'll charge you, and the charges will accumulate on a monthly basis. It's not expensive, but just saying, endpoints are, I don't think we used it, but this is, I think, going to cost money. There is a NAT gateway. If you create one, it'll also cost you money. If you have a peering connection, if you create one, it'll also cost you money. Peering connections are connections that you want to peer with another VPC that you might have. Security groups don't cost you money if you have a custom setup, for example, your company has, which is a customer gateway that you can connect. And you can create a customer gateway and assign a BGP ASN number and make a way for your machines in your data center to route to the Amazon's cloud in your VPC. That's a possibility. This costs money. Your company may have a private gateway or some other way of connecting to the Amazon's cloud. or some other cloud, any cloud you might have. There is also a possibility of establishing a VPN connection. That I don't think we did that exercise, but we will do that exercise later on in another subsequent hands-on session, in which we will have a method of establishing a VPN connection. And this, yes, it does cost money. For our case, we'll use an open source product to create OpenVPN. We'll use this OpenVPN product to create a VPN connection. This is open source. So it doesn't cost you a thing apart from the machine that will run the software. And that machine will, of course, cost some money. But this is the solution that I would be demonstrating from a live example perspective to set up a connection between all your company employees within the company and have them connect to a private area, like the VPC, for example. We'll do these exercises later on right now. Not right now. Okay. I'll close this window, close that one also, and I think we wrapped up that hands-on exercise. I want to talk a couple of different things and do another idea that I did not do yet, which is to understand, I think, SSL. So how many of you have already used this idea called an SSL certificate?
I have a little.
Okay. So when you get an SSL certificate, what do? You go to Veritime and you buy a certificate, right? Something like that. Is that what you did?
Mm-hmm.
Okay. So what I'm going to tell you is don't do that anymore. Don't go to these companies. There is no reason to. Instead, you do this way. Companies will charge you like whatever they want, $100, $300, $800, whatever they come up with, right? Whatever number. But instead, I suggest using this one. This is an open, free, automated certificate authority. It is sponsored by a long list of big companies. The sponsors, donors, but this is open. The thing is, you want to understand this is open, meaning it is open source. How it is run, the source code is open, the service itself is open to everybody and anybody on the planet. It is free, it is perpetually free, and it is automatic, meaning completely automatic. I mean, you don't even have to go to somewhere to get a certificate. You just set up some code to make it happen for you. That is how you should run it in every single setup. If you look at our sites in Cloud Genius, you will see them, all of them have a certificate assigned by the Let's Encrypt authority. And that is how we do it. And it is valid till whatever date, Friday, June 15th, 2018. That is something you should remember, that this certificate is a short-term certificate. It's only given to you for 3 months. So you would question, why would I get that? I usually receive certificates for like 2 years, 3 years, 1 year sometimes. Why would I bother a 3-month certificate? So the response to that is, you should not worry about it because it is automated. Meaning the process of receiving a certificate the first time is automatic. The process of receiving and renewing a certificate before the expiry of the first one is also automatic. So why bother? It's completely automated. And you will see a live example right now. Let's go to some example code. In here you will have, I will look up some exercises for us to do. I'll identify that. It's a new one. So it's a newly written exercise. I'll go find it. And it's a fairly new setup. So I'm going to just hunt it down. Oh, there it is. So we can do it multiple different ways. You can do a self-signed certificate, which is not what I'm talking about. But instead, I'm suggesting that we use
a SSL based certificate. There it is, that exercise. I want you to do this exercise. So I'm clicking it and giving you a link in Slack chat. That's the exercise I will be doing right now. This will give you a good idea of what Let's Encrypt is and what is going to do for us. Like here, it gives you a certificate. This certificate for Let's Encrypt itself is also automated. It is issued to themselves by themselves and their authority. And this is the expiration date. And that's also automated. So let's see something live. What I want to do is run this exercise. And that exercise involves a couple of things that we haven't yet discussed. For example, Docker containers. And we'll discuss them. We'll go through complete understanding of what Docker is and how it works and why it's important and all that. But right now, this exercise will use Docker. Just saying, it is going to use. That's how it is written. By the way, by doing it this way, it actually does the work very, very effortless. So the fact that we are using Docker makes life easy. And you will see how easy it can become. And what I'm going to do right now is run this live exercise in a remote location. In a remote machine, meaning any cloud you pick. You pick your cloud. So I'll pick some cloud. So here we go. So we can use Amazon Cloud or DigitalOcean Cloud. So I think we are connected to Amazon already. So we'll just use it right there. We have to create a machine, right? So we get a running instance. And I will launch an instance. And I will launch an Ubuntu machine, like right there. And by the way, I will not complicate our examples for the VPC discussion. I'll just use the simple get a public IP address, put it in the default VPC and get me an IP address, which is already public. And we're not talking about subnets and all that complexity. We'll deal with that later. Not right now, not in this example. In this example, all I'm doing is just generating a simple setup with a T2 micro machine, configure the details, put that in the default security group, or sorry, default, whatever that thing is. What is it called? Let me make it full screen. I think it is too bright for me to look at. I am, I think I'm facing sunlight. So let me shut this down a little bit, some of the windows. It's too bright for me to even see my own screen. Yeah, this is much better. So I can see the screen. Otherwise, almost I was going blind to the sunlight. So now I see that I have one machine that I want to create in the default VPC, which is one given to us by default. And I don't care which availability zone I get it in, but I want to get a public IP address. I enable it. And then I just add some storage, and then I add some tags and add some security groups. And I use the existing security group I have, which is a public group. And it's kind of open. Open to me, open for HTTP, open for HTTPS. Yes, correct. That's nice. So I launch right there. So the machine is getting ready. In that machine, I want to run a bunch of Docker code. It's a ready-made examples written for us. So we'll use them right here. So what I'll do is, first of all, make sure that that machine is set up with Docker. So I will run Docker in there. How do you run Docker? There is a simple method of doing it. And it's written down right here on this website. And that method is right here. We'll just copy it and run it in the machine that we now have. The machine we have to first of all connect to it. So we'll go there, get the machine IP address. The machine IP address is available to us in this location where we have a public IP right there. So we grab it and then connect to it. Like that. We connect it. Now in this machine, what I want to do is run that, sorry, not this, run that script that I have, which is going to set Docker up. That script. it gets Docker script. Now I have the script and I want to run that script. So running is simply I think it will ask me for a sudo prompt. And so it seems to be going through okay. So it will set up Docker, by the way. On the machine, we will set up Docker through this method. So we'll wait for this to finish. And then it finished. Then I want to do is this last step that you have to log out and do this one last step defined here. So we will do that. I just did that and I log out and then I log back in. Now I have Docker already there. Okay, Docker is there. Now I want to run the demo. And I will show you what I just talked about is getting an SSL certificate from this authority in a completely automated fashion. So what I'm doing is making sure that I'm mapping my domain that I have to some name corresponding to this IP address, the one I have, which I connected to. And so I need to go to my control panel in my domain control panel and associate this thing with a domain name. For example, the domain name I want to use is some other name, like this, some other. So I'll use that name. I'll go to Cloudflare, identify my domain, go to the DNS section, and there I'll create a record for some other. And then assign a IP address, which I have from the Amazon cloud, which is right there, this IP. So grab that IP address, and I'm basically labeling this IP address as my some other .cloudgenie.us DNS name. So I made that association between the name some other and this IP address. Having done this part, I would like to test it. How do I test? I go back to my console and say dig and then some other. Who are you? Give me your A record. So I receive my response back as the same IP address which I created. Now this is a necessary step for the automation to succeed. Automation for encryption and getting an SSL certificate to succeed. This piece is necessary. You need to have a name associated with an IP address. That is actually where you need to run the code. So whatever code you run on that IP address or that box needs to actually have a name to number mapping, like an A record in place and functional and correctly validated. This is how Let's Encrypt Authority will actually test for validation. Having done this, what I will do now is put in a product here. It acts like a load balancer, if you will. So that load balancer is what I'm going to run. And it is a container level load balancer. We'll discuss container level things later on. But all I'm showing you is right now a architecture that I'm building, which looks like, let me show it to you. So we have to have a load balancer here and a companion. This companion will interact with Let's Encrypt and receive certificates. And then I will run my application. So there will be a load balancer connecting to the application, and I will visit this site. This site is called some other .cloudgenie.us. That's the name of this site. Actually, this site that I will be hitting through a load balancer. So first thing I'm creating is actually creating a load balancer inside Docker. And yes, it is going to be new for you, so bear with me. We'll go through Docker parts of the exercise later on. But for right now, I want you to understand and focus on how this companion application will provide an interface between the Let's Encrypt Authority and allocate
a certificate. So it will ask for a certificate. It will receive a certificate. It will actually validate whether are you the same address that this points to. If that validation succeeds, then it will issue a certificate, and that certificate will be assigned to the load balancer. And then any subsequent traffic that comes through HTTPS will be served using the certificate that you received. Come the time of expiration, 3 months is when the certificate is valid for. So come about 60 days, this companion will kick in again to automation, and it will again ask for a revalidation. It will again check whether this name resolves with this IP address through a challenge validation, and that challenge validation has to succeed. If it succeeds, it will give you a renewal certificate, and this companion will put that certificate with the load balancer, and you have a new extension. And you keep on going through that. Extend after that. Every 60 days, extend it. That's the process you will see. In the process, what I will be doing is creating this load balancer, creating this companion, and creating an application. All of these things on the same box. Because Docker is running in containers, so you will see these things happening all in the same box. Containers are a different animal, not VMs, but we'll talk about containers later on. I'm just using them right now. So I'm going to create these 3 containers: a load balancer container, a companion container, and an application container, and then tie them together. The code is written down already. Here is a load balancer container, the first one. So I'm not going through the details of what this thing actually does, but just understand that this is going to run a load balancer for me, and not here on this machine, but instead I need to go to that machine and then run it on that computer in the cloud. Not running it. It's going to run it and create a load balancer for me using Nginx is the load balancer, and it is right now running using Nginx proxy. You can see it running right here, and it's there. It's up and running for like 7 seconds. Next, what I want to do is run the companion container, which will allow us to grab certificates from the authority, which is a separate image. So we'll run this piece of code, which we'll go through details of this code. Don't worry about it. For right now, I'm running the second companion, second container, which is a companion. It will set up that companion also and finish. So we now have 2 containers running, the companion as well as the proxy itself, meaning the load balancer itself. Now comes the time of running an actual application. What I want to do is make sure that I invoke a application that runs some Apache code in the same box in a Docker container, and it is going to do that thing for me. And as a consequence of this run, you will see that it is actually going to get a certificate from the Let's Encrypt authority, and we'll see what it does when we examine its logs. You will see the actions it is taking as to what's going on. But at the end of this right now, we now have 3 containers running. Let's go see them. I have these 3 guys running: the application itself, the companion, and a load balancer at the very top. That's what we showed you in the picture here: a load balancer, a companion container, and the application itself. Now these 3 are configured together already, and we should now visit this URL, and you will see that it is already HTTPS. You should see that. Let's go see it. So we'll go see here, open it up. Let's go to some other .cloudgenie.us, and boom. And what do you see? Oh, I should type HTTPS, should I? And what do we see? Cannot open. Okay, that means we failed. So let's see why we failed. It did not work. So we'll find out why it did not work. And so let's go check the logs. So we have the companion is what we should watch for logs, and we'll go examine the logs for this companion container. And so we'll say docker logs and this guy, the companion, and we'll pipe it through more and see what's going on. Oh, it takes time. I forgot to tell you. So it's going to take a long time. I told you that. I forgot to tell you that it's going to take some time. It takes about 2 minutes. For the first time, it has to generate these Diffie-Hellman group parameters. It's a long prime number generation method. 2048-bit long safe prime generator is running right now in that companion, and that takes time. But that's the reason why we are waiting for this to happen. But in the meanwhile, let us go and watch that log. Instead of piping it through more, I will just go logs in a tail. So we'll tail them. And there's the parameter generation happening, as you can see. This is how it looks like when you run it. The parameters are generating right now. And you will eventually see that this finishes in a matter of a minute or so. And then you will see this companion interfacing with Let's Encrypt and accepting a challenge, responding to the challenge, receiving a certificate and putting it in the right spots and all that. And at the end, you will have HTTPS, completely automated. It should work. There is no reason for it to not work unless I made a mistake, in which case we'll fix it. But I think I did not make a mistake. I think I did not, but we'll find out. The real test is actually visiting the site and seeing if it is HTTPS or not. So that's what I'm waiting for in this. So it will show up soon. But this is how you should do SSL certificates going forward. You know, stop paying money to companies to get certificates. Even in Boeing, don't do that. This is a highly reputed, open, and automated certificate authority. You should use this. By the way, one thing I would like to point out to you is Boeing company is not using SSL certificates. That's a problem, I think, right there. No SSL. That's a problem. I want you to know. I want you to tell people in Boeing company that please consider this as a priority. I know this is not a priority for Boeing. That's fine. But you don't want to see a picture of Airbus showing up here. Sorry, but I'm just joking. Not that this will happen, but this could happen. I'm just scaring you right now, because it could happen that somebody can hijack your DNS and make a man-in-the-middle attack and replace the picture of a Boeing plane with an Airbus plane. That will be a disaster waiting to happen. I'm not kidding, but that's what I'm seeing. That's what I'm seeing. I'm just scaring you guys, nothing else. I hope you understand. What I'm saying more clearly is that Chrome will enforce HTTPS starting July. There we go. So there is this news that you will see that Chrome browser will mark all HTTP sites as not secure. Meaning people who visit Boeing.com will see the flag here that says not secure, Boeing.com, not secure. That is not what you want to show your customers, right? So that's why I'm saying, please tell people to do something. I'm just sincerely telling you to do something. This is a necessary thing to happen. We don't have too much time. It's July, and right now it is April. So only a couple of months, and you will see not secure flag right there. It will show like this. I'll show you an example right there. This is how it will look like. Not secure, Boeing.com. That's what you will see. And the real risk is man in the middle attack, which is, imagine somebody in, say, American Airlines, who's your customer, and they open Boeing.com in their company, and they're running through a man in the middle attack of some sorts, and they see an Airbus. Bad idea. Don't do that. Just saying. And I'm seriously saying that, seriously telling you guys, please talk to your people, tell them this is happening. This is happening in July, so get ready. You want a link? I will give you a link right there. Please read and please do it. Okay.
Thank you for that.
I know I don't want to scare you, but it's a fact of life, man. So just understand that. And so let's go to some other. What do you see? Here. And we see it. We see HTTPS right there. Let's go click on that. And we see a certificate issued by Let's Encrypt Authority, expires July 5th. Today is April 6th, which means it is exactly 3 months. And it was just issued like 5:46 PM, which is like right now almost. Is it? Yeah, I think they go by number of hours as opposed to 3 months. So it was issued like right now. You can see the logs right here. You can see the logs now, the prime number generation finished. And after that, you see a couple of things. What do you see? It sleeps for 3,600 seconds. Then it generates Let's Encrypt data from 3 containers. We have 3 containers running, right? It runs a service to engage with Let's Encrypt. It is watching for Docker events. It looks for the contents of this service data did not change, so it is skipping this notification. Then it is reloading Nginx proxy, which is our load balancer. It looks for the default .configuration from 3 containers. In there, it finds out that there is a need for a creation or renewal of a certificate for this domain. So it generates a new account key. That account key generation has a warning. Apparently there's some deprecation going on. So that's eventually the update. You don't have to worry about this deprecation right now. We'll next see that using this simple protocol, you implicitly agree to the certificate authority's terms of service. The terms of service are called out in this location. You can see the document, the terms and conditions of Let's Encrypt Authority. Then it generates a new private key. It is saving the account key, saving the key.pem, chain.pem, full chain.pem, cert.pem, and reloads the load balancer. And then it generates a new configuration that includes the Nginx proxy, new load balancer containing your certificate, and then sleeps again for 3,600 seconds. It is currently sleeping. It will wake up and do its thing and then go to sleep again. It has nothing to do, it'll do nothing. If it has something to do, it'll do that thing and then sleep again. That's how it works. That's how this companion works. We have a total of 3 containers running here. This is the application itself. The companion occasionally sleeps. And this guy is the load balancer. It is actually serving you HTTPS, as you can see, 443 and 80. And you can see it right there. It's a valid certificate. You can see it, access it, and all that good stuff. So that was the other exercise, which is, I think, an important thing I wanted to bring to your attention, even though we haven't covered Docker quite yet. And we haven't even discussed it. But I wanted to tell you about this thing and see how simple it is to actually implement. I know it is not a priority for the Boeing company, but it is going to be a priority soon. So please tell people in your company that they should do something about it. I mean, they not something, they should just shut up and get an SSL certificate. And yes, this Let's Encrypt might take time. It might take you to understand what it means and process follows and all that. Okay, just spend some money, get a known certificate from a known entity that you already know. I'm not saying you go this route. All I'm saying is, please get an SSL. That's it.
That's what I wanted to say. That's the reason I did this exercise, to show you as to why it is important and how you need to do it for your own company, that you're not doing it. And I have a problem with that. I don't want Airbus picture to show here. That's not what I want. I don't want a disaster to happen. There'll be news, by the way. There will be a big news if it happens. So I don't want that to happen. And therefore, I hope you got the point. Okay. So any questions on this? Forget Docker thing, right? Forget the Docker part, but just understanding the concept of an automation and getting a free, open certificate authority. I think that is beautiful. Won't you agree with that? Or do you like spending $800 on VeriSign? Is that what? I don't think you like that. But just saying that this is the dominant, I would say this is the only way going forward. This is how you should do it. There is no other way. Big companies are doing it like the same way. And people like Chrome, Facebook, they are in the game.
So, Nilesh, one quick question. For open source items, are there any security concerns? So the code is open to the world, right? Is there any ways that someone can, say, create some type of app and it's open source and they can put some malicious code in there and then everyone starts using it? Is that even a possibility?
Yes, and I'll tell you why it is not actually a possibility, but yeah, it's a valid concern. I'll answer that question. It's a good question. So first thing I would like to say is that by keeping things open makes it a little bit more secure than keeping it closed. That's a general statement. I just made it. The reason I say that is that if you have lots and lots of people looking at some piece of code, it's available on GitHub, for example, right there. And so thereby, there are lots more eyes that are examining what that code is doing. So you know what the devil is and you are ready to deal with the devil. As opposed to dealing with something you don't even see, don't even read. You implicitly trust somebody to take care of the problem. That is called closed source, right? When you're not open, when you're closed. You don't even know what the devil is. They don't tell you. You just trust them blindly. You pay them money. They'll ask you for more money to fix something and you pay them more money. And you blindly keep on trusting them. And that's okay sometimes. It's okay that you trust Microsoft, you trust Apple, you trust Google to create operating systems. Do you trust this guy? Do you trust this guy? Do you know this guy? Do you?
He's pretty responsible for Linux, isn't he?
Yeah, he created Linux about 30 years ago. And Linux is used in 90% of the cloud today. And his code is right here on GitHub. It is the source code. You can see the Linux kernel source code in a tarball and view the diff and go to browse it. And all the source code for Linux is right there for you to inspect, like right here. So I think this clarity of what exactly that thing is, you can see and read and implement and build it yourself, actually makes products more secure as opposed to less. Now, the reason why I think Gustavo asked that question is this idea hidden under his mind. And I'm not trying to read your mind, but correct me if I'm wrong. But I think the concern that originates from most people that are not familiar with the idea of open source is the fact that, just because it is open doesn't mean that, you get to pick and choose whatever people will be putting in there in GitHub. Doesn't mean that. Here's what it means. We'll use GitHub and we'll use the Docker source code, for example. And so here is the Docker source code. Now there's this change that happened in 9 hours ago. somebody made a change. Somebody who? Gordon the turtle. This turtle guy, they have fancy names. So this dude called Gordon the turtle, that actually looks like a turtle. This guy, he works for the Docker company at the Lars desk. And he made a change in Docker. Now, how did he do that? This turtle? He did that because he is actually a Docker employee, by the way. And not only that, he is, sorry, where did it go? Where did it go? Here. His change that he made in Docker's main source code was reviewed and approved by a bunch of people already. Let's go see what he actually made, a commit. He made a change, and we'll do a Git exercise soon so you'll understand Git things a little bit. And we'll go do hands-on with Git so you'll really get clear understanding. But what he's doing is he's changing versions of some things. He's also changing some hashes here, and that's what the change he made. Now this came down as a change that he incorporated, but it was reviewed by a bunch of people together with him. There are how many people? There are 1,826 contributors. Here is the community of people that contribute. There are 1,820, like maybe 100 of them are Docker employees, but there are other rest 1,700 are outsiders, not part of Docker company. There are these guys, 1,826 contributors. There have been 52 releases, 11 branches, 40,545 changes. So people have been making changes to it quite a bit. Like it's a fairly popular product. 9 hours ago was the last change. The version that we have currently running is tagged at this version, 18030 RC. So that's the version that is currently stable, and these are release candidates. And so what I'm suggesting is to Gustavo is to not be afraid of open source, but understand what are you dealing with and carefully limit the variations that will happen in open source. Things will change, like this Gordon the turtle comes along and he wants to make a change, and he's making quite a bit of change apparently. He's the one that is apparently the last person to actually commit and make a change happen in this repository. As you can see, almost every single thing for the last couple of months is done by Gordon the turtle, this turtle guy. And so that's okay, but he's not doing it alone. He's being reviewed by a bunch of people. He cannot just generally commit anything. But more importantly, you should limit yourself to a latest stable branch or a branch like 1804 that you know works good for you before you test it and put it in production. And you lock yourself to that specific version. That's how you minimize the exposure of variability in open source. But actually, I would argue that open source makes it better for you.
Okay.
And
nope.
for your company.
That makes sense. Thank you.
You're welcome. And I'll pause recording. I'm still open for questions.
No questions on my side. Just have a good weekend.
Thank you.